Hi, my name's Guy, and today I'm going to tell you how and why I built my very own well over engineered weather station. First up, a bit about me. I've been writing software for more than 30 years. For the first half of that, I even got paid for it. Professionally, I'm now an agile coach and delivery lead, but I'll always be a software engineer at heart. After graduating in 1992 with an engineering degree, my first real job was writing real-time control software for a remote pipeline repair system. I wanted to use the skills I learnt then in this personal project now. So why did I want to build a weather station? Well, the short answer is I didn't, but I did need a tangible goal to aim for. I wanted to prove to myself that I still had the skills to build a real-time control system as I did in the mid-90s. I also wanted to learn some modern web technologies. A weather station seemed like a good fit as it could have the components I wanted to build. That's a real-time scheduler, serial communications, analog to digital conversion, and of course a web front end. So why is this possible now? Development boards for microcontrollers were and are very expensive, as were microcomputers. However, with the development of the Arduino platform and the Raspberry Pi, there is now a much cheaper option for enthusiasts. You can buy a cheap Arduino clone for around £8, that is about $13 US, and a Raspberry Pi for around £35, which is about $43 US. Now I'd like to take you through the architecture and design of the system. So what design criteria did I have for my weather station? Well, I wanted to use analog sensors. This was also something the Arduino could handle, but the Raspberry Pi couldn't. I wanted it to be field programmable. I didn't want to have to open it up to update the software. And I wanted to challenge myself by building a real-time control system, as previously stated. And I wanted to do that in C and C++ with a JavaScript front end. Here you can see the architecture of the system. We have a Raspberry Pi Model 2 and an Arduino Uno clone inside the weather station. The Raspberry Pi sends commands to the Arduino using serial over USB, and the Arduino responds. There are temperature, pressure, humidity sensors connected to analog inputs on the Arduino. There is provision for rainfall and wind speed monitoring, but I haven't added those yet. That's something I hope to do in the near future. The Raspberry Pi performs an HTTP post of the weather data to the web app deployed on Heroku, and also backs up the weather data to a Postgres database running on another Raspberry Pi on my network. Here are the circuit diagrams of the three sensors. I drew these using a free online circuit drawing system that allowed me to download them as a PDF. This is a circuit board layout of the sensors with the required components. I drew this including all the components in Keynote. It's not the best software for drawing diagrams, but it is simple and effective. You could probably achieve the same thing in PowerPoint if you wanted to. This is a video I took before I assembled the weather station. Apologies for the slightly shaky camera action. On the left is the Raspberry Pi with the Arduino on the right. You can see the reset line that enables the Raspberry Pi to reset the Arduino. The onboard LED flashing once a second. This is controlled by the heartbeat scheduler task, which we'll get to in a moment. You can also see the RX and TX LEDs flashing, showing the serial communications working. Finally, you can see the sensors inputs plugged into the Arduino. The serial protocol between the Raspberry Pi and Arduino consists of a request frame at least 6 bytes long, and the Arduino responds with at least 7 bytes. Both the request and response frames include a checksum to aid error checking and can be a maximum of 80 bytes long. Here are a couple of photos I took before I sealed the weather station. On the left you can see the electronics inside their box. Actually it's just a pencil case, and the three sensors for temperature, humidity and pressure. On the right everything is inside the protective outer case, and that's just a piece of 100mm pipe. Now I'd like to take you through a quick demo of the weather station software. First I'll log on to the Raspberry Pi that is inside the weather station using SSH and tail the log file. Now I'll open the admin console served by the Raspberry Pi software. This supports control commands on this page and also allows me to calibrate the sensor readings on the final page here. I'm going to turn on debug login from the console and we'll see the output go to the log file. If I now turn off debug login again, we can take a look at the output. Here you can see the request for weather data sent to the Arduino and the response here. The data is sent as the raw values from the analog to digital converters. You can also see the weather data being posted to the web app here. Now I'll show you the web app. You can see the main screen here showing the current temperature, the air pressure and the humidity, as well as the minimum and maximum value for today. These are reset at midnight. You can also view graphs for the last 24 hours, the last 7 days and the last 28 days. This is the data for the last 24 hours. Each data point is 20 minutes apart. I'm going to show you a selection of code snippets. You can get the code yourself from my public repositories at github.com/Guy Wilson. Look for the RT scheduler, AVR weather, weather CTL and weatherapp.js repositories. The software running on the Arduino is written entirely in C and built using the AVR GCC toolset. It uses my real-time scheduler that I also wrote for this project. The software runs on an ATmega328P microcontroller, clocked at 16 MHz, with 2K of RAM and 32K of flash program storage. It is interrupt driven, with interrupts for the real-time clock, which drives a scheduler and fires every 250 microseconds. The RX interrupt, which is triggered on a serial receiver of a character. The TX interrupt, which fires when the transmit data register is empty. And the ADC conversion complete interrupt. The software responds to 8 commands via the serial link and is field programmable by the Raspberry Pi. This is a program entry point. You can see that it initializes a scheduler, registers some tasks and then schedules the task to run, one of which is a heartbeat task that flashes the onboard LED. This is a schedule loop. It is called from main and never returns. It simply loops around the registered tasks, checks to see if each task is scheduled and if it is time to run it. If so, it calls a task function. Tasks must run as quickly as possible and must not wait for events. Events are either triggered by an interrupt or can be polled by scheduling a task repeatedly. This is a simple task to illustrate the anatomy of a task function. This is the heartbeat task. It simply checks if the LED is switched on, and if so, it turns it off and reschedules itself in 950 milliseconds. If it is off, it turns the LED on and reschedules itself in 50 milliseconds. So the LED will flash once a second, on for 50 milliseconds, off for 950 milliseconds. This is a task that responds to a serial command frame. It is scheduled from the RX interrupt once a valid frame has been received. The code gets the minimum, maximum and current readings from the ADC into a structure, builds a TX frame and begins transmission of the frame back to the Raspberry Pi. The software running on the Raspberry Pi is built on Ubuntu Server 1804. The CPU on the device is a quad-core and clocked at 900 MHz. It has 1 GB of RAM. The software is written in C++. It is multi-threaded with 5 threads plus the main thread. The threads will auto restart on error. I have configured it to run as a service, so it starts automatically on power up or reboot. I've also written a bash script which I've called Jenkins with a G. This runs as a cron job every 5 minutes and checks if the software has been updated on GitHub. If so, it pulls down the latest code, rebuilds and restarts a service. Here you can see the code that processes a response from the Arduino to the weather data request. It logs the weather data, as you saw in the demo, and pushes it to the queue to be sent to the weather app on Heroku. This is the code that calculates the centigrade value from the raw temperature sensor data. This is called from the class that posts the data up to the web app. Here's a thread runner function that runs each thread. If the thread throws an exception and exits, it sleeps for 1 second, then auto restarts. The web app is a Node.js application deployed on Heroku. You can find it at wizzy-weather.herokuapp.com. The REST APIs are secured using JSON Web Token, and the front end is served by Express. The app supports graphing for the last 24 hours, the last 7 days, and the last 28 days. The weather data is stored in Postgres and retrieved by the graphing routines. I did try MongoDB first, but that didn't end well. Here's a REST API that the Raspberry Pi software calls to log in. It fetches a user by email address from the database, compares the SHA-256 hash of the password against the hash value stored in the database, and returns a token back to the caller if authentication is successful. This is the API that the Raspberry Pi software calls to post the weather data. If the authentication token is verified, the data is read from the request body. So, some conclusions from my experience. I'm 50 years old. Trying to see the tiny components to solder them together is really difficult. I achieved my goal of writing a robust real-time control system with little or no debugging aids, and I'm quite proud of that. Spending all of my free time in the zone when I was coding got quite annoying for my wife and family. I found front-end tech really frustrating. I'm used to procedural programming language. You can probably tell that I focus my efforts on the back end rather than the front-end code. Don't try to use MongoDB. The documentation is appalling and the examples don't work, in my experience. If I can do this, then you can do it too. And thanks very much for watching. I hope you enjoyed my presentation. I'll be available to answer any questions you may have.
Thank you so much for that talk, Guy. That was just brilliant, and a subject very close to my heart is hardware. So first question to you, what are your next steps for the weather station? What are you going to do next with it?
So I want to add a rain gauge and wind speed sensors. I envisaged adding them right from the start, but I was originally going to build them from scratch, but that proved to be beyond my mechanical engineering skills. So I thought, okay, I'll buy some, but they're quite expensive, so I've kind of left it for now. They're probably about as expensive as the rest of the weather station put together. I will get some, but it will have to be a bit of a wait for that. The other thing I'd like to do is link it to openweathermap.org. So that's like an open weather site where you can contribute your weather data from your own weather station to the site. It's got APIs. It's relatively simple to use, I think. I'd like to do that, and then I think I'd also like to look at some kind of simple prediction algorithms. Nothing too fancy, but something that basically tries to learn and try and predict what the weather's going to be like. Obviously not in the next week, but maybe in a few hours' time, so based on the weather data that I'm collecting. Very difficult, obviously, because weather's very unpredictable by its very nature, but I thought I'd like to give that a
UK.
Especially in the UK, yes.
I was going to say the weather in Arizona would always just be warm, except for a winter monsoon. So it'd be like, we have two weather patterns, hot or not hot, and that's it.
Excellent.
It sounded like quite a challenging project for you to get to the point you did. Was there anything that you would have done differently looking back on it now, and why is that?
I suppose what I would have done differently is more from a kind of hardware point of view. I think I would have looked at getting the circuit boards fabricated.
Yeah.
Simply because I use kind of generic prototype boards, just basically a circuit board with a load of holes drilled in it. And with my 50-year-old eyes, that was very difficult to actually physically see. See to solder. The components are tiny, and I found it really hard. I think a prefabricated circuit board would have been a lot easier for me, and it would have worked first time, which was my effort didn't. It took a few goes with the soldering iron to get it to work.
Good practice, though.
Good practice, yes, but I'm not entirely sure on its long-term reliability, but we'll have to wait and see. Been out of the garden about 6 months now, so and it's still going strong. So.
And what have you got coming up?
So, well, after the weather station, what I've been thinking about is flight telemetry kind of stuff. Obviously, like when they launch rockets, they have computers on board that send data back from the flight back to Earth. Maybe obviously it's something not quite that fancy, but maybe something around sort of drones, maybe some kind of autonomous flight control systems. The other thing I'd really like to do is launch one of these helium balloons that fly up into the upper atmosphere and take pictures of the the curvature of the Earth. I'd love to do that. I think both those things are probably quite expensive, so that might have to wait a while. Other than that, I don't know. I'm quite interested in cryptography as well. I've written a program where you can hide basically a file of your choice into a bitmap or a PNG. Always been interested in that kind of thing, so I'd have to think about something around that as well. So.
Sounds like you've got an entire conference worth of talks.
These are like half-stack ideas for the next 5 years. Yeah.
One thing I would ask of everybody is, I'm pretty lonely on GitHub, so if you fancy going on there and following me, that'd be appreciated.
It's nice when you go from like 2 stars to 3 stars. You feel really important. So, like the one is yourself and the other is your mom, and you're like, please, someone else follow me.
Yeah.
So you mentioned earlier on what I think was breadboards, the make your own circuit boards. I used to use those in a previous role with kids, and we used to mock up robots with that kind of thing. Do you think that is a good way to start working with hardware capabilities, or would you suggest another starting point for people?
No, well, yes, I think it is a good way. I started with a non-solder. I think they're called breadboards, but I'm not sure. But you just plug the devices in basically, and that's how I got the circuit working. I knew it was going to work, and that's a great way to play around with hardware. It's relatively cheap, doesn't require any soldering initially. I think it's a great way to learn about electronics. I did a degree in electronic engineering, so I've got a bit of a background in it. But even so, it's been years since I've used any of that knowledge, so getting back into it was quite challenging for me, but I felt I understood it better than I did when I was at university. It's a bit of experience behind it. So.
Are there any resources that you would recommend that you use to get back into it?
Any resources? I did use like an online circuit diagram drawing tool. I can't for the life of me remember where it was, but it's free. It allows you to download the circuit diagrams as PDFs as well. So I designed the circuit diagrams initially on there, and then obviously built the circuit board layout diagrams from that. So.
Nice. Yeah. And do you have any advice? So I'm assuming that a lot of the people who are listening today are web developers and might not have used C or C++ before. Any advice for them getting into coding for hardware?
Obviously, you can code with hardware in many different languages. Obviously, Python's well supported on the Raspberry Pi. I'd recommend looking at that. There's a lot of third-party libraries out there to help interfacing with the hardware on the Raspberry Pi. So take a look at that. I didn't want to do that because I wanted to get right into the bare bones of it and do it all myself.
So the answer is don't don't get into it.
But do by using Python. If you're not a C or C++ programmer, go with Python or maybe sort of Node.js or whatever. So whatever suits you. There are libraries out there. Lots of people have written libraries that you can use with different languages. So. And with the Raspberry Pi being so inexpensive, it's a great tool. And also the Arduino as well. Obviously, the Arduino has a sketch language, which is very simple. Again, I didn't want to use that, so I wrote it from scratch in C. If you write a sketch in Arduino, it compiles down to C++ in the end anyway, so it uses the same compiler.
Nice.
Spoken like a true developer.
Yeah.
I'll write it myself.
So, Guy, how have you been managing dealing with COVID-19 and staying at home? And like, I think you said you moved north about a year ago or so, right?
Yeah, well, no, a few months ago we moved kind of east, I suppose, out of London, which I'm glad we did because we've now got a reasonable garden. I don't think we would have, we would have gone insane living in the place we did in London, where it had a very small backyard. So I'm glad of the outdoor space. Actually, it's been okay. Got my family at home, obviously. So
you're making Joe jealous with your comments, I can tell.
Yeah, my postage stamp garden.
Yeah. So, I'm currently on. I've been furloughed, which, if you don't know, it's basically a government scheme whereby your employer can choose to basically pay you through the government scheme rather than pay you themselves, because all our projects at work have shut down effectively because of the COVID-19. So most of us have been put on furlough, which is great because I can just enjoy the summer. It's fantastic. It's been really nice weather.
And over-engineer a second weather station, so it's great. Yeah.
Well, work on my next big project. Yes.
Indeed. Anything tech-wise you're hoping comes out soon that might make your life easier for the types of things you want to build?
Trouble is, I don't want my life to be made easier.
Okay. That is a total engineer answer. I love it. That's great.
That's what drives me, really. And if you've never done anything with hardware, I'd urge you to do so, because there's nothing better than seeing something physical happening from the result of your code, even if it's just like a little LED flashing. It gives you a great buzz.
Last year's the first time I built something with hardware that did not catch on fire, so it actually worked. It was amazing, but usually it's just smoke and fire. And anyway.
I did manage to blow up 3 Arduinos in the last big project, but
cool.
8 piece, it's not too bad.
Well, thank you so much for making time for us and for sharing your stories. And I've already liked you on GitHub, so now you have another friend, and we're good to go. All right. Up next is Chris Heilman. Thank you.
Thank you very much indeed. Thank you. Take care.